What's up, team? Today we're solving generic equations or solving for a given variable. Say we're given this equation 6x plus 9y equals 36. That's currently in standard form as we've learned it. Say we want to convert that to slope-intercept form. Slope-intercept form is in the form of y equals mx plus b. And right now this is not the case. So what we're going to do is we are going to isolate the variable that we want to get by itself. So we want y equals mx plus b. So we're going to solve this equation for y. That means we got to send this 6x to the other side. We got to send the 9 to the other side as well. We're following all the same rules of algebra we've been using for years. The only difference here is we have to make a decision. Are we solving for x? Are we solving for y? In this case, we're solving for y. So let's see what this looks like. First thing I'm going to do is I'm going to subtract 6x from both sides. And when we do so, we learn that 9y equals negative 6x plus 36. Boom, boom, boom. Okay, cool. Now, we still don't have the 9 or the y by itself. We've solved for 9y's. That's cool, but we're interested in what 1y equals. So we'll divide this by 9, we'll divide this by 9, we'll divide this by 9. And what we see is that y equals, well, this turns into negative 6/9 y plus 4. And this can be simplified ever so slightly. So it's y equals, negative 6/9 is negative 2/3 y plus 4. And now we have the equation in slope-intercept form. It's got a slope of negative 2/3. It's got a y-intercept of 4. Of course, this y right here should be an x because right here it's an x, and then I turned it into a y on accident. So let's clean that up. This one should also be an x. My mistake. The math is good. I just wrote the wrong letter down. Whoops. Okay, so that's how to solve this one for y. Well, let's say for some reason you want to solve this equation for x. I don't know what the circumstances would be, but we can do it. So same exact equation, 6x plus 9y equals 36. Now I'm interested in finding out what does x equal. So this time we're going to subtract 9y from both sides. And when we do so, we see that 6x equals negative 9y plus 36. Keep going. Divide both sides by 6. And we see that x equals negative 9/6 y plus 4. And this can be cleaned up again ever so slightly. And we see that x equals, this is going to be negative 3/2 y plus 4. Now again, what value does this equation have to us? I don't know, but we can do it. It's true. We started with the same equation in standard form. Over here in red, we solved for y. Here in blue, we solved for x. Great. Let's look at something a little bit more, applicable to real life, I suppose. This is the equation where you can convert a temperature in terms of Celsius into Fahrenheit. So if we knew what the temperature was in Celsius, but we wanted to figure out what it is in Fahrenheit, we just plug it in here and simplify, then we'd have the F already by itself. Well, what if we don't know what the temperature is in Celsius, but we do have it in Fahrenheit, and we want to find out what it is in Celsius? That means we got to flip this whole equation around. So we're going to solve this equation for C. Right now it's solved for F. We are going to solve it for C. So this is the variable we are aiming to isolate. The first move is subtract 32 from both sides of the equation. So we see that F minus 32 equals 9/5 C. Okay, fine. I'm going to rewrite this ever so slightly because remember, C is the same thing as C over 1. And so I'm going to do this multiplication. I'm going to say F minus 32 equals 9C. I'm getting too smushed here. Let's give it a little more space. F minus 32 equals 9C over 5. I just multiplied these two fractions. 9 times C is 9C, 5 times 1 is 5. And what that's going to do is it's going to make this next move a little bit simpler. I'm going to multiply both sides by this denominator because when we multiply both sides by the denominator, it gets rid of the fraction. So multiply by 5, and that means we have to multiply this entire side by 5. So now we have 5 times F minus 32. We'll do this distribution in a minute. Equals 9C. Distribution. So now we have 5 times f and 5 times negative 32. 5f minus, 5 times 32, let's see, 5 times 30 is 150, 5 times 2 is 10, so it's going to be minus 160 equals 9c. Now, again, I'm trying to get the c by itself. I'm so close. We found what 9c equals, so let's figure out what 1c equals. We'll divide everything by, not by c, whoops, we're going to divide everything by 9. So divide this by 9, we'll divide this by 9. This is our final step. Thanks for sticking with me on this one. So we have 5/9 f, or this could be 5f over 9. Those are the same statement. Minus, 160 divided by 9. I came ill prepared, so I'm going to grab my calculator. 160 divided by 9. We end up getting 17.7 something. Gross. So I'm just going to leave it as 160 over 9. We'll leave it like that for now. Equals c. So this equation here, oh man, I feel like this could be reduced. Does Thanks for watching this riveting part of the video as I try to figure this out. I think we're dialed in. I think this is going to work for us. So now what this tells us, if we know what the temperature is in Fahrenheit, which is what we're used to, we could plug it in here, carefully PEMDAS this business, and then we would figure out exactly what the temperature in Celsius is. Pretty cool. All right, last one, and this is actually the quickest one. At the same time, I don't want to say it's the most common use for this skill, but it's somewhere where you've maybe already seen this skill at use, or you will in the near future. So in the context of science or physics, we know that the rate of speed times time equals distance. So if I'm traveling at a certain speed, whether in a car, on foot, on a bike, whatever, I'm traveling at a certain speed for a certain amount of time, I can just multiply those two values together and figure out how far I've gone. For instance, if I'm traveling 60 miles per hour in my car and I'm traveling 1 hour, well, 60 times 1 is 60, and so I've traveled 60 miles. So that's how this would be used. We'll say that we want to solve this for r because we are curious more about the rate of speed because we have the rest of the information. So what we would do here is, well, this is the variable we're trying to isolate. Right now we have r times t equals d. So I just want r by itself. I need to undo the multiplication by t. That just means I'm going to divide both sides by t. I don't know what t is in this context, but I know it's a number and I know what to do. I know I can do this with numbers. I can divide, multiply, add, subtract, whatever it is. So t divided by t is 1. 1 times r is r. So r equals d divided by t. So this was just a one-step equation. So it's interesting because all these had numbers in it, so they feel more comfortable. This one only had letters, but it's actually the easiest one to work with out of all of them, given our starting points here. Okay, so to recap, we're using the same rules of algebra we've been using for years. The difference in what we're doing today versus what we've been doing is there's multiple variables at play that you're given, and your task is to solve for the given variable. In an equation like this, I didn't write it on the board, but I would have said something like, okay, 6x plus 9y equals 36, solve for y. Like that sentence would be there, solve for y. So you would know which one to solve for. It's not a guessing game. And this one, I would tell you to solve for x. This one, I would tell you to solve for c. And this one, I actually did write the statement, solve for r. So in our practice problems today, when you dive into our notes and check that out, all of them will say, here's some equation, solve for this given variable. Okay, let me know if you have questions. You got this.